Should I get started?
I would say yes.
Okay. Okay, welcome everyone. You are participating in the session investigating data discovery across domains. This is organized by Data Discovery Paradigms Interest Group. My name is Ming-Fang Wu. I'm one of 4 co-chairs of this interest group. Photos is on the screen, and Yoda hiding somewhere. And I would like especially introduce our new co-chairs, Catherine, Gregory, and she pretty much come with this interest group from the beginning. Now she finished her PhD study and has more time to spare. And we are grateful and Catherine join us and be co-chair and co-leading this interest group further. Okay, please be aware this session is being recorded. Please turn off your camera and microphones if you don't want to be in recording or you while you are not speaking. And if you have any comment, please type in chat. If you have any questions that need answer or clarification from speaker or from anyone else, please type that in KOA tab. We will go through that questions after each presentation. And collaborative notes, photos could it's in the link is in the chat already. Please put any comments as well in the notes, and also please remember to add your name to the attendance list. If you want to tweet, that's RDA plenary handles for you to use. Here is the agenda today. We will start with introduce of the group, what this group doing and how we get along so far, and updates on the one group activities. Then we will have 2 presentations on data discovery. Then we will discuss future activities of this interest group. Then wrap up with future actions. Okay, so I will give introduction to this interest group, as many participants here are new to this group. So really, this group is trying to address the fundability of in the fair data principle, especially the principle says metadata are registered or indexed in a searchable resource. This keyword metadata index and searchable are really we trying to focus on. As each of these keywords represent a bucket of words by 3 key players in this data discovery cycle. So we have data providers. They provide metadata, the content to be searched for. So what metadata or attribute to users to their particular search task we would like to understand. And data discovery service providers, they choose index, what to index, what is the ranking model to put into in their system and the search interface for users to discover data. And users, they have a data needs, they come different backgrounds, their understanding of a discovery system and the metadata structure are varied, and all these impact on their data discovery experience. So with all those spectrum stakeholders in focus, and the objective for this interest group is to provide a forum where all these representatives from a spectrum of stakeholders and the roles can explore shared issue of how to improve data discovery. We also try to produce actionable recommendations for different stakeholders. So how we organize our work. So initially at P8 and 9, so we ask members to nominate interested topic. Based on the members voting, we top 4 most voted to start with. So we started 4 task force along each of these topics. Guideline for making data findable, use cases, metadata enrichment, and relevance ranking. So 3 of these 4 task force produce supporting outputs. So first output, 11 quick tips for finding research data. So data discovery, data search is a skill. So we kind of framed by keyword search, by web search engines, but there are more into that if you have effective data search experience. So this material can be used for learning and training materials for people who want to improve their data search skills. And the second output, user requirements and recommendations for data repository. So this task force collected about 80 user cases. About 40 of them are about the portal functionality. So we abstracted about 9 user requirements based on these user cases. We did environment scanning, applied usability and usability heuristics, and based on that, we provide about 10 recommendations for data repository, what kind of functionality, the ideas to have to support user requirement and user cases. And the third output is a survey of current practice in search surveys. So this survey has a very narrow focus on what the ranking model each data discovery surveys put in place. So there are about 98 of data repositories around the world participated in the survey. You can have a look of survey to see where we are at. The motivation we did the survey is we trying to find the most popular ranking models deployed by data repository. So the following up task is we could build test collections to run against these models, so we can set up a benchmark and also provide advice to data repositories how they should configure their ranking models. But you can see that that's a very resource intensive, so we stop short to reach that goal. But you will hear today from one of presentation how that work can be organized and to do that kind of evaluation. Okay, that's the output cards from RDA. So after we finish those 3 task force, then we start 2 new task force, data discovery on granularity and using schema.org for data discovery. So the data granularity is started as a working group. They will have their first plenary session at breakout 4. Please join them. And also the schema.org for research data discovery also started as a working group about 4 plenaries back. And this group are about to discuss their output in this plenary. That's in breakout 8. Yeah, so then we also started a task force called the user study of data discovery. So that's the only task force we have for this interest group. Yeah, for those people, I look at chat. If slides not moving, trying to refresh your Chrome or whatever web browser you are using. Yeah. Yeah. Okay. So that's how we travel so far as interest group. So now I give a brief update on the user study activities. So in last year, this user study activity pretty much at the stage of exchanging each other's work. You can see we have a list of presentations here. We have a monthly call. If you want to know individual study, all slides are available. So there are a range of user studies. Some did a log analysis, some did a survey, some did interviews, some did an anthropology approach to observe users in natural environment. Some did implement novel data discovery interface, so you name it. There are lots of good studies and research here, but mostly stayed in the academic kind of research, if you want to. Meanwhile, in our relevance ranking reports, I said before, we have about 98 repository participate in the survey, while only a quarter of them did a kind of user study or evaluation of their system. Majority of them didn't do any evaluation. But those repositories express that they understand the importance of doing so, but the lack of resources. So the question for our user study task force is how we bridge or transform the research findings into actionable recommendation to improve data discovery surveys. About 2 weeks ago, Photos sent out a survey, asked people to vote and nominate the future activities for this interest group. So you can still vote if you go to collaborative notes or slides, then you can follow the link and do the voting or nomination. Okay, that's introduction of the group. So now we have 2 presentations on data discovery. So they will tell us 2 data discovery projects, national or international-wide data discovery project. So our first speaker is Professor Michael Aldis. He works at the Department of Molecular Life Science, University of Zurich. Michael leading a co-chair the Elixir Beacon project. So welcome, Michael. I'm handing over to you now.
Thanks, Ming, for this. I try to, let's see if this works again. Okay, I hope Does it look orange and Elixir on it? Then it's...
Yes,
Okay.
looks good.
Great. So I look a bit to the side, so sorry, because different screen. Okay, yes, thanks for the introduction. So I represent today the Elixir Beacon project, and now, interestingly enough, here's a lot about data discovery, and this is more about discovering something in the data, but I'm also a co-chair of the discovery work stream of the Global Alliance for Genomics and Health, where we have the topic discovery is more wider, boxed in, so also including the discovery of data resources. But also this is part also of the Beacon project a little bit. Let's talk about Beacon. Beacon project is a project of the Global Alliance for Genomics and Health, and it's but the development project is run by Elixir since 2016. So what is Beacon and why do we need this? This is now a slide from our research, what we are doing. So we run here in Zurich one of the largest annotated, completely open resources for structural genome variation data in cancer, progenetics resource, where we look at copy number data. And also we collect all the literature associated with that. And from collecting the literature and mapping everything, we also can do this meta-analysis. And here you see a picture already, what is you're all aware of that resources, data resources people are interested in are widely distributed worldwide and not evenly distributed. So, but this information is also important. So this is just a map of nearly 4,000 cancer genomic profiling studies and how they have developed over time and where they have been done in the world and where the samples come from. So data is everywhere, and the paradigm now, which is being followed in many development schemes, is to look at this as a kind of how can data be federated? How can it be accessed through at different locations and not in single unified repositories? Also, these big repositories are important because we run them too, right? So this is the concept of the Global Alliance for Genomics and Health, which was born to enable a bit this paradigm in the area of genomics in human diseases and human health. So GFOGH stands for Global Alliance for Genomics and Health and wants to build a federated ecosystem for the sharing of genomic and clinical data. Clinical data is here very loosely. It's not electronic health records, but it is additional information relating to bio features and so on, which makes it data better interpretable, but not delivering everything that is private to the patient or very widespread or very complex trajectories, but more the core data. And the idea is here to have something where people that have protocols and tools and software and also agreements on how users then at some place in the world can sit at their computers in their research or as private users and make use of these APIs. And so to learn a bit about genomic data and get benefits from it. So it's for the benefit of human health, as in the Declaration of Human Rights of the WHO. So, of the Declaration of Human Rights and stated by the WHO. So one of the early protocols, or the main protocols, which directly was thought of when in 2014 was the Beacon protocol, which I will talk about. And this is basically a protocol. Beacon is to make data accessible first, that people find it, but then also to explore the data. And what is Beacon? Beacon had been in the originally a very simple protocol. And the idea was basically to be able to send a simple request out to the internet and about, for instance, there's a variant at a given position, a genomic variant here at chromosome 17 SNP, and then get some result. And the result was thought in the beginning planned to be super simple. It was mostly about getting engagement, getting buy-in, getting people really opening their data and really figuring out in their local institutions, can we open our genome collections now to the outside if we just provide this absolute minimum information about existence, yes or no, maybe frequencies of a given record, of a given genomic variant. So as a public web source, and this is what Jim Ostel presented at the first GFOGH meeting in 2014, So public web service, which basically answers this question as I just shown. And because, it has been a dark and quiet place in the internet for genomics then, right? And still mostly is, but we are making a bit of headway. So finding willing participants, trigger issues which may block this reuse, and get a real signal from real data, and leave then the implementation of more important usability features for later. And this was being taken up. So in 2016, there were lots of beacons from many organizations, from different genomics centers, different hospitals, interested research groups, and so on, sharing this data. But the utility of this is obviously quite limited for very practical issues, right? So there isn't much. No, for some rare diseases, it is useful if you have newly identified variants you haven't seen anywhere. You can send out a request to a beacon and to a network, and then see, okay, this variant is known or this isn't known, and so on. But otherwise, it's not very practical. Now, but this was seen as something, okay, there are lots of buy-in. Now, how we can make this more practical? In 2015-16, Elixir stepped in to support this as a collaborator of the Global Alliance for Genomics and Health. And there was now the plan how we can make this more biomedical. Yeah. So there are many changes needed. So you have to enable non-aggregate patient-derived data sets. Actually, the first beacons were mostly like VCF files, mostly aggregate data, just this yes, no. Biodata parameters, how can we select just some features, some individuals, some samples. Ubiquitous variance formats, so not only SNPs, right? And local secure environments, also that people can start to use the same protocol in maybe their secure enclaves, so that then part of this protocol can then also be used for data sharing more easily, because you use the same standard. And data delivery over beacons, although the normal beacon protocol does not allow any data delivery for privacy reasons. To enable this, this was obviously something that is wished for. There had then been development in the first years, and in 2016, and later then version 1.1, which was approved as a standard by the Global Alliance, then already included some structural variant support, handover for data delivery, that is giving an interface for sending data, but outside of the beacon protocol, and maybe then protected by another security framework, and also interfaces for using AAI. And then already it was clear we have to do a big update, version 2, for really adding other stuff, and for instance, filters for phenotypic and technical metadata, and large-scale deployment. This just shows how in version 1 already this handover protocol works, that you have basically a beacon query, already showing some of the features for version 2, where you go in your internal resource, you have a matching, and then you get your beacon response just says there is something, and you get an ID, and an on-the-fly generated ID, which you can then use through an authentication system, if the protocols allows this, and if you're authenticated, to use then other protocols to deliver the data. But still, it's not part of the beacon protocol itself. But this was already first step. We are actually using this for our completely open progenetics database. This is really using the beacon at its core. So we have beacon queries, and we have handover deliveries, and then the handover deliveries are used for asynchronously pooling the data from our own server, and then populating something like you can see here, like here's a copy number variant frequency histogram from lots of cancer samples following a beacon query. Yeah, this has already been possible, but it's a circuitous way a bit. Importantly, beacon network. I mean, I showed already for the early version that beacons are network. That's the power, right? But now Elixir, with the Elixir AAI and with the controlled development, now has opened up to build a new network. It's not only for Elixir, but also for external contributors, but where we start now to explore, and this is done mostly by Elixir Finland, that to build a network where different resources can then are then supported for newer and improving query options and more structured data delivery. And this is just an example. So it's an integrator throughout Elixir human data domain and also looks beyond Elixir already. Now we have been working for a while on Beacon v2, and there are big changes. And development is mostly done by the group at the CRG and Barcelona, and the network part a lot from Finland, and we are also contributing a lot to the API development and testing. So specifying query types for multiple types of genomic variants, access levels, so what's your authentication level? Are you authorized to use Beacon, not only as an open protocol, but are you a scientist? Are you identified, or are you just verified? There are 3 levels, basically. Filters basically allow ontology, any ontology term, I come to that, being used if the resources support this for the queries by sample patient variant, evidence, and so on. And also to define and explore cohorts of data, not only is this in your resource, but is this in a certain cohort of individuals or experiments. Now the biomedical part starts to come in, and this slide obviously has to be read in with a bit of time. If you are interested in it, they are posted here, and I will post them also on our side. This is an evaluation basically run under the guidance of Jordi Rambla in Barcelona, who was sitting with many stakeholders together which have interest in biomedical data, so networks of hospitals and so on, or variant annotation initiatives. What is basically needed to make beacons more biomedical and therefore interesting as an expanding data standard for many stakeholders for practical use cases. Yeah, and then here you have this clinical workflow. And basically you have a data model, a domain model basically on how we separate now the most important domains, which is actually a bit under development still, but we have subjects separated from biosamples, technical information, sample observation, I call them samples for the observations, and then the variants from these observations are then the variant instances, and on the other hand, interpretation of genomic variants and so on. This is just pointing to the filters concept, which is at the core of the additional data, the non-variant data queries in Beacon v2. And this is an example also how we use it in our website, where you have basically hierarchical. We use here the NCIT cancer ontology, so neoplasm core ontology, basically for mapping diseases in our database in the query, and then you can select also hierarchical level and say, okay, all the child terms and so on. So this is very, very helpful, and this concept is being documented right now. I come to that. We explore more structural variants. It has been a bit of a pain because people have lots of different ways to think about structural genome variants. Cytogeneticists have a completely different concept frequently from people doing whole genome sequencing and thinking in VCF files and so on from the cytogeneticists and from clinicians. So there has to be actually lots of groundwork to be done to really do some definitions on how we make this clear, what is being queried in the variant space and how it's being done. And I co-lead one of the work groups there. This is just an example showing of some paradigms which will be possible with Beacon v2. For instance, simple queries which are now not only on the specific variants, but saying just, okay, in this region which you define genomically, give me anything, or give me any structural variant there, or give me any variant which leads to a genomic variant which leads to a generation of a double T also in this region, in this gene, for instance, in your collection. Bracket queries are very powerful in that, and this is simple range, just between here and here. You will do bracket queries which allow you to shift it, start and end regions to overlap against each other, and basically be able then with that to match any type of contiguous genomic variant. And for instance, this is another type of bracket query where we basically say, oh, give me a CNV, it should cover the whole gene, but it shouldn't be too big, so it shouldn't start much distal or then the gene start and so on, approximately. Okay, Beacon project. What's important here? Elixir is driving this as a core of lots of collaborations and interactions here with many different organizations. And it's not only Elixir driving that. I mean, it's a GA4GH project. There are other stakeholders actively participating, but there's lots of involvement here with different organizations, and they are kind of listed here. Rare diseases important now, beyond 1 million genomes. I come to that. H3 Africa, Bionet, and others, HCNV community, Swiss networks, and so on. And here's also an example how the Beacon development fits into the strategy of involvement of Elixir in the Beyond 1 Million Genomes initiative, where Beacon is, as an accepted standard, already being part of this bundle of GA4GH related standards being pushed into the development of the infrastructure for Beyond 1 Million Genomes project, and how this is also then being part of the data discovery there. Nearly done. So we are working now on these V2 standards, some features of which you have seen here. And so the large changes from Beacon V2 will require that we will submit this as a deeply updated standard to the Global Alliance for approval. And this will be done in summer for the plenary in late September. The current work is now on brushing things up, working on finalizing the schema, query model, and on documentation, which is always something which comes a bit late, but this has to be really solid if submitted to the GA4GH for approval. We know the process. And also there are updated reference implementations. So for our resources, we have our own implementation. We wrote ourselves, but also a reference implementation is provided by the Elixir developers, so that people can just download and test instances of beacons for themselves. And there is now, we've just started to test drive multiple implementation, that is, ask all different stakeholders who have their own to provide their endpoints, and then to benchmark, and not benchmark in terms of speed, but benchmark in terms of correctness of query and response use there. Okay, submission soon and approval hopefully in September. So Beacon, the first slide, as you saw, this was a very simple question. Is this specific variant somewhere in your resource, and then sending it out? Now, Beacon V2 is more like that, federated data discovery. And here you have an example of how a Beacon query then looks parameter-wise in V2. So you have a variant query which specifies genomic region for deletion being there. Then you have code, which is the NCIT code, which is a disease code. So Beacon will make use of these ontology terms of queries, based ontology terms mostly for these filter queries. So we are very interested in driving those standards here. This would be NCIT for glioblastoma, Duo code for dataset with unrestricted access, and then an HP term for HPO term for is it the juvenile patient. Beacon protocol itself won't prescribe which terms can be used, but this is then part of the data sharing umbrella that the resources will announce what types of annotation systems they use, what types of data they have. And this will also be done using GA4GH standards like service info. So you can then you can query beacons already for their content, not in what they have in data, but what types of metadata and what formats they use. So Beacon V2, this is then one step to the Internet of Genomics, genomics being here very widely used for genome-associated data, chiefly in the human context, but there are many explorations regarding non-human genome data. There have been COVID beacons by the guys at EGA and CRG actually, and by DNA Stack in Canada. There's interest from French groups working on APRICO genomes, for instance. So it's not only a human thing, but the development comes from GA4GH, which is obviously human, targeted at human diseases and health. Here are some links, some information. We have a website, a Beacon project. It's always a bit updated. You find some information there. Then on the right, you see the GitHub, the development arm of where the protocols really reside. Basically, it is one open API document defining the standard. And then here, for instance, is a link to our website, which also uses Beacon at its core. API leads, Jordi Rambla, Jordi Rambla leading the team in Barcelona and the main Beacon development. Tony Brooks comes in for rare diseases, especially, and Juha Turnhorst leading the network development. I'm the head of one of the heads of the GA4GH discovery workstream, which chairs then the Beacon project from the side of GA4GH, but we are very involved hands-on in the development, and Sabella is one of the main developers of the code itself. And this was it from my side. Now I need guidance for questions and Q&A. Thank you. So I'm shared.
Yeah, Michael, for the presentation. Are there any questions for Michael? There is a comment instead of questions in chat. Claudia said, so I have not thought of before as sharing clinical data. Or I think is on.
So you mean, so is this now for Beacon or GA4GH? I mean, GA4GH is huge. There is a lot of different areas. The Global Alliance for Genomics and Health is basically, yes, it's a starting point, what we are talking about, if it's genomics, but lots of work is focused around this, but it's certainly a bit wider than that. But yes, that's the kind of the condensation point. Somehow, mostly there is some genomic flavor, even if you talk about patient consent, which doesn't have to be for genomics data. So there has been a big output from GA4GH regarding consenting to data use by patients, and this is not limited to genomics, obviously. But it is driven by, also we have to make this clear, what patients or individuals in a wider sense, what rights they have and how they can influence what happens with their data. For now, the associated data, I mean, in principle, like Beacon is, we run on our resource, we also run queries, for instance, not specifically querying variant data, but just give me all the samples from a certain study or so. So which can then also be done because we use a query for the PubMed ID or for the GeoGSE or whatever you have there. So in that respect, it's open. But yes, we work with genomics data, and that's what we are okay. But it's, as I said, the protocol gets more and more. The genomics is rather not so complicated. It's more the standards are, even if they are sometimes a bit finicky, it's kind of easier to understand than what annotation space you have in clinical data and how this is normalized at the back end.
Thank you, Michael. I have a question. So if I understand correctly, you add a new type of query when a need arises. So how quick turnaround, you put new query type?
So actually, the thing is that Beacon doesn't try to be prescriptive in what query parameters you use. So we had I think 2-3 years ago, we only started to discuss how we do this filter concept, and we had very early. So what we are doing, we have a developer version which is always some steps ahead and tests out what could be done, and we started to use queries as identifiers because this came then, and then lots of problems associated with you have to map your data and so on. But with that respect, we don't say really, what type of data can be queried, but what are the basic formats, right? So if you have, and for instance, there is now this documentation is already there, but not public yet in depth. So resources can decide what do they. I mean, you can, for instance, query age of a patient by using an age object, which we actually take from phenopacket. So there's always this alignment, but you can also do it by using an HBO term. And then it's the question, what does your resource support, right? So in principle, many of the features which in principle can be queried are just not being bound by format, but by support through the resources. And there it's important that there is kind of an alignment. There are other things which have been principal features which change the structure, are something like cohort support. You say now, okay, it's not, this is something because it's a logical concept, it's a logical entity where you have then your query in a certain logical space. So this is then an added feature which is now paradigm shifting a bit in how this works. But mostly it's about saying it could be done that way. It's not so often that one says, oh, we need a completely different umbrella for that.
Cool. Yeah, thank you, Michael. And we will move on to the next presentation. If you have a question for Michael, put in QA, and so Michael can answer you. I type answer in QA, so have to move along. So our next speaker is Makoto Kato, and Makoto is a social ed professor at the Faculty of Library, Information and Media Science, University of Tsukuba in Japan. And he will introduce us Japan National initiative on the data search. So over to you now.
Thank you. I'm very pleased to have a talk here. Thank you very much for your invitation. So I'm Makoto Kato from University of Tsukuba. And this project is organized by I and Hiroaki Oshima from University of Hyogo, and Inshan Liu from University of Southern Denmark, and Xindian Chen from Missouri University of Science and Technologies. And this, before talking about this project in detail, I'd like to introduce what is this NTCIR. So this is a kind of evaluation forum. If you know about Trek in United States, it can be considered as Asian Trek. And in this evaluation forum, we try to develop better systems, especially such system, with the cooperation between the task organizers and participant. And we have two roles. One is a task organizer, and task organizer design task, some information retrieval task or information access task, and prepare task collection and evaluate participant system. The other side, the participant develops system to achieve better performance in the tasks. So we collaboratively work on the same problem and try to develop a better system. So that is an evaluation forum. And this NTCIR started in late 1997. And we have been developing many kinds of task collection, including science, news, patent, dataset, and it's also includes web search, community Q&A, Wikipedia data, and we develop many kinds of task collection based on these kind of dataset. And our language scope includes Chinese, Korean, and Japanese, and English. And our tasks are very diverse, including IR tasks such as query, very standard query-based retrieval system, or geographic object search system, or math retrieval system. And our focus also includes Q&A system or NLP task and data mining task. And we have been organizing many rounds of NTCIR, and now we are in NTCR 16. But today I'd like to talk about the 15th NTCIR. And in this round of NTCIR, we have 7 tasks as shown here. And I'd like to talk especially about the data search task. And this task, NTCR 15 data search, is the very first IR evaluation campaign for data search, as long as I know. And if you access to this website, you can see the details. And you can also download the test correction. So if you're interested in this project, please visit this website, ntcir-datasearch.jp. And this test correction consists of Japanese test correction and English test correction. And these corrections include around 100 of training queries and test queries. And this includes some relevant judgment data, which I will talk about in detail later. And this in this evaluation campaign, in this shared task, so our main task is the ad hoc retrieval for statistical data or dataset retrieval task. And as I said, this task focuses on 2 languages, English and Japanese. And we prepare 96 queries for each of the subtasks. And our document collection, so we try to retrieve some data set from dataset collection. And for Japanese task, we use eStat. This is a governmental dataset portal website. And for English task, we use the data.gov data. And we expect such system produce a long list of dataset for each query. So here's a nice figure illustrating our task. So we have a query, for example, city population 3 million. And given this query, so the system tried to find a relevant dataset from dataset collection. And then it produced a linked list like this. And this is evaluated by task organizer. And participants try to produce better result. All right, so here's some example of topics and queries. So we prepare these kind of topics and queries and distribute them to the participant. So for example, one of the examples is, are there many people who can't drive large trailers? And this is a kind of intention of the user. And based on this intention, we assume that a user input this query, people can't drive large trailer. And we just use this query and try to retrieve the data set relevant to this query. So that is our task. And as I mentioned, so we use 2 types of data collections. So one is eStat. This is a Japanese governmental dataset portal website. And this consists of over 1 million of dataset. And for English topics, we use data.gov as a dataset collection. And this website consists of over 40,000 of dataset. And as you can see, this dataset also includes some metadata, such as title or short description about the dataset, and data itself. I mean, the data sometimes CSV data or PDF file or some other type of format. And we actually crawl this website and provided this dataset to the participant. Here's an example of dataset. And as I mentioned, they have metadata, and they include title and short description and when it was created, and some more information about dataset. And the actual data file are sometimes a spreadsheet like this, or spreadsheet like this. So this is these are example of dataset. And so as I explained, we encourage participants to develop a better system, and we compare the participant system. And for comparison, we also provide a baseline method, which and participants try to produce a better result than this baseline method. And as a baseline method, we use very standard retrieval models to only the metadata. So as I said, our data set consists of metadata and actual data file. But we, as the ordinary data set search system do, we just use the metadata for indexing each data set. So we just try to compute the matching between the query and metadata by using very standard retrieval models. So so we use the retrieval models such as BM25 plus some pseudo-relevance feedback techniques. And there are many kinds of variants, but we tried many kinds of algorithm, and we use them as a baseline method. And as a task organizer, we prepare queries and dataset collection and distribute them to the participant. And we receive the system output from the participant. As a result, so we received 54 system results, and 17 for Japanese and 37 for English. And we attract 4 teams in this task. So these 4 teams submit 54 system results in total. And here's the evaluation protocol. So data sets retrieved by each system were evaluated by human assessors. So we hire some the assessor and ask them to give either 0, 1, or 2. And 0 means not relevant, and 2 means highly relevant. And then, so here's a query, and system outputs some result, and assessor judges each of the data set and decide which one is relevant and which one is irrelevant. And then we compute NDCG at 10. And this is a kind of a score indicating the quality of top 10 retrieval result. And this was used as a primary evaluation metric in our task. So each participant output is scored by this NDCG at 10, and we compare this score for the submitted rounds. And we have several questions about this dataset retrieval task. And we mainly focused on the difference of the proposed method of participant teams. And we have these kind of questions: what techniques were potentially effective, and what queries were difficult in dataset retrieval task, and is the topic variability large or not? So we addressed these 3 questions in our analysis of the evaluation result. So here's the overall result. And I'm showing the NDCG at 10 for English topics and NDCG at 10 for Japanese topics. And each bar represents each system developed by the participant. And you can see some alphabet above the bars. And you can see N, C, T, and whatever. And these alphabet indicate what kind of method was used by the participant. And if you know about NLP, very recent NLP models, so N stands for neural language models. They include BART or Robata. They are the very recent techniques for modeling the natural languages. And T stands for table header extraction technique. So I explained our baseline method, and that doesn't use the data file itself. But this table header extraction method use the metadata as well as table headers for indexing the data set. And there isn't very clear trend in this evaluation result, but these two techniques, the neural language models and table header extraction techniques, are potentially effective in this dataset retrieval task. And let me skip the detail about these approaches. And for the second question, so what queries were difficult in dataset retrieval? So to answer this question, we classified queries into 3 types based on what type of entities are included in the queries. So queries sometimes include location name and time and numbers. For example, location as a location, maybe Tokyo population. So this query includes the location name, Tokyo. And this query includes time, 1990. And this query includes numbers, so 2 million. So we classify the query into these 3 types and compute NDCG at 10 for each query type. And we found that location query is not very hard for the dataset retrieval task, but these time query and number queries, they are especially difficult when we compare to the average performance of all the queries. So the one finding might be these 2 types of queries are a little difficult to process in this dataset retrieval task. And the third question is a topic variability large or not? This graph shows the NDCG at 10 for each query. And this bar represents the distribution of NDCG score. And if this bar is long, this means there is a large variability of the system performances. And if this bar is at the low position, which means that query is difficult. And we found that there are a variety of queries in the task collection. Some queries are very easy, but some queries are very difficult. And the topic variability is very large compared to the other kind of task. And we also found that no single system performed better than the others for all the query, which means some systems are very effective for some type of queries, but they are not effective for other type of queries. So we have much room for improvement in this task. So that's the main message from this analysis. All right, so in summary, so this project, NTCR Data Search, is an IR evaluation campaign for data search where task organizer and participant try to make a better algorithm for data set retrieval task. And if you are interested in developing better data set retrieval algorithm, we are running the second round of data search tasks. So if you are willing to develop a better system, please participate in our task. And please visit our website for details. Thank you very much for your attention.
Thank you, Makoto. We have a few questions for you. In QA, I think the first question be answered. What index metadata or data? In your later slides, you said to the metadata and metadata be indexed, and there are second question. What is a search? No, that's a question for Michael. Let me see. How was the topics derived?
Good question. So first question is about which field in the metadata are used for indexing. Am I right? Sorry, I missed the first question.
The first one, okay. I trying to skip that one, but maybe we was the queries against the content of dataset or metadata associated with the dataset?
Okay, so for that question, so it depends on the participant system, and so there are metadata and data file, and our baseline system only use the metadata, but some participant, for example, this result and this result, this T indicating they use the actual data, the data files. So this result and this result and this result. So this system utilize both metadata and data files. So that's
okay. Thanks. Yeah. So you provide both metadata and data, then it's up to participants what to use.
Yes.
Yeah.
And
Thank
second
you.
question is about how did we make topics?
Yes.
Okay. So sorry, I skipped that point, but so there may be two ways to make topics. One is using query logs in this kind of data retrieval system, and another way is we took another way. So that is we use a Q&A website question. So there are many questions about some statistical data. For example, what is the population in United States? So we manually extract such kind of data from the CQA system, for example, Yahoo Answers. And we in Japan, we also have a CQA system, and we extract such kind of question, a question about statistical data. And then we make topics based on their question. So they are kind of real question from real users.
Thank you. There is a question about the number, number queries. So people can't derive large errors. Doesn't include a word indicating a number was solved. Would it have been better to add how many? So if people add how many in together with number, would be better result?
Can you say it again? Sorry.
If I understand your question correctly, is that if people send number queries, if put how many together with the number, will that improve search result? Is that your question, Suryoda?
Right. I was saying that number queries scored low, and I noticed in your sample query, the string that was derived from the natural language didn't include how many, right? So I would expect it to perform well. Yeah, there. See, people can't drive large trailers, whereas really, how many people can't drive large trailer was the question. But I guess you weren't expecting the system to return a number. You were expecting the system to return a data set from which the user could derive the number. So, but still, it didn't perform well, you're saying, because it was looking for something that would give a numerical answer. So would changing the query improved the performance with respect to queries that were looking for numerical results?
So if I add how many to the people can drive large trailer, can it improve the such result or not?
Yes.
So if we use a very basic algorithm, it doesn't improve the result, I think. But if the search algorithm understand the semantics of the query, so if we add the how many, so it may indicate that its user want to find numerical information, so that may improve the result, I think, especially for yes. That's my answer. Thank you.
Okay, thank you, Makoto and Michael. Thank you for your presentations. There are still a couple of Q&As. If you can, could you please type in your answer in Q&A? I'm just conscious of time. We have another section of work to go. Thank you.
Thank you.
And thank you. And now our next section of this session is to discuss the future activities of this interest group. I will hand this over to Fotters.
Yeah. Give me a sec. I think I have this ready. You should be able to see my screen, hopefully.
Yes.
Perfect, thanks. So as you've seen the first agenda item in the first slide where the agenda, we have opened up a survey about potential new topics. The survey is still open, but the results you're seeing are basically the outcome of about 20 minutes ago. So there might be some changes there. So the idea was to ask about 10 topics that have emerged in the meantime since our last survey about potential topics, and get a feedback from the community about whether it's generally interesting, a topic, and whether people would be actually actively like to contribute if that was a data discovery interest group activity, and even better, if they would be interested to actually lead this activity if it starts. The numbers that you see on the side are basically corresponding to each of the colors in the same order. So generally interesting, would like to contribute, would like to lead, and not relevant. And I bolded out the numbers of responses corresponding to contribute and leading. The topics, and I'll go through them briefly, are talking about, as you can see, fairness in repositories and how this fairness would have an implication on data discovery. Talking about searching data logs as a means of data discovery, deduplication scenarios, meta-analysis of user interviews. This is very closely connected to what was discussed so far. Data citation practice and metrics. And then we also have a few more about upper level ontologies so that the data discovery process is improved. Search personalization, method enrichment, cataloging APIs, and machine learning for data discovery. The last one is going to be extensively discussed by Siri Joda in a second. Organizing the results, basically doing a very broad ranking based on responses. These are the three main groups that I see emerging. So the first group are cases where there is high interest in being an activity within the data discovery interest group, plus there are people that would be interested in actually leading that. This is evident. So this are ordered, again, by the number of responses. Keep in mind that the number of responses so far are 20. So it's not a big number, but it's adequate enough, I think, to get a better understanding of what is going out there. Metadata enrichment for discovery is one of the top ones. 11 people expressed that this is an activity that would be interesting, actively contributing within this data discovery focus group, data discovery interest group, and there are at least 8 persons that would be in actively leading that. I would like to highlight that I've only seen the aggregate results. So if the people who are interested in leading those things are right now participating in the session, I haven't done any connection yet, so I'm just putting it out there. The second most highly ranked one is about using upper level autonomous for improved data discovery. 9 people were interested in the interesting part for me. There are 2 people that are actively interested in leading that, which is quite important in my mind. Third is the machine learning for that discovery with 1 person leading, and then we have cataloging and APIs with 6 people finding interest to be contributing as an activity in that discovery interest group and 1 person leading it. The second group are cases where there's a low overall interest, not as a topic, but looking at it as a topic for people to have as an activity within the data discovery interest group. So I'm looking again at 4.2, 3.1, and 3.1 correspondingly. Data citation practice and metrics. This is kind of an edge case in my mind, because although there were only 4 people out of the 20, so roughly 20% that were interested in contributing to activity, 2 of them were also leading. So I would assume that the overall number is about 4 people. Again, it is a good starting point, but I was a bit on the fence about this. Fairness in repos is an interesting case because a lot of people found it quite interesting. And if you look at the results, it's actually the most highly voted one. But if you look at it as an activity that will be actively taken up within this this interest group, only 3 people were actually interested, and 1 was interested in leading it. Searching data logs is on the lower end with some interest, but overall quite low. The last section is cases where there's a high enough interest, more than the previous one at least, but there were no people actually interested in leading that. So these ones might be useful to keep in mind, unless there are people that will be actively engaged in taking this role at this point. And with that, I will stop the discussion on this point. Are there any questions or comments about this the survey? The plan is to keep the survey open for at least a couple of weeks after the plenary, and maybe send a couple of reminders also on the mailing list. So these might change slightly. However, please bear in mind that the key element that we are looking for here is whether people are interested to actively contribute to the activity and ideally leading it as well. I don't see any points in the chat window. I don't see anyone also unmuting. So I will stop sharing my screen now and give the floor to Shraddha.
So I did type something there in the, hi folks, thanks. I did type something in the chat there because it wasn't really a question. It was a statement that if the topics around data citation and fairness with respect to discovery were going to be pursued, there really have to be a careful study of what's going on with other RDA groups that are all over these topics.
You're absolutely right, and I just realized that I had one extra slide that I did forget to present, which is that there were also some additional topics proposed by the response, which I really forgot to highlight here. So these are additional topics that provide us free text as other ideas. I will go through them again fairly fast because I'm mindful of the time. But this is one of the points that was also raised here, that we need to make sure, both in fairness as well as of the PIDs, for example, data citation, that other efforts that have been done by similar working groups and interest groups are connected, ideally having a common task force, for example, or a common working group, if that is the best approach. But as you can see, there are also some interesting ideas here about studies about evaluating many sets of data, which is alongside data discovery, domain-specific user studies, semantic ranking, interactive data visualization, and long-term sustainability of queries. So all those are interesting points, and we will definitely keep them as part of the discussion. You can always see those results in the slides, which are shared, and everyone should be able to access them. So yeah, please keep this in mind. And now I'll stop sharing again. I think the floor is yours now. See each other.
Okay, so I don't need a slide share if somebody wants to just keep going in the slide set.
I can do that. Sorry, give me a sec. I will start sharing my screen again.
And God, if there was time, I think some discussion around those proposed topics. First time I'd seen them, because I hadn't looked in the survey recently, would be interesting, because I have thoughts on all of those.
I personally won't be against having a discussion, but at the same time, I know that we have less than 10 minutes to the end.
Oh, right. Okay, let's jump. Okay, so let me just jump into this. I think I've got just one slide right on machine learning. Yeah. Okay. Good. So of course, artificial intelligence, machine learning, of which machine learning is one of the methods, is behind all modern search engines, and it's embedded, in fact, in almost everything we do when we interact with the web. But what are we talking about when we talk about data discovery? Yeah, well, what are the applications, current applications, and what's sort of the unexplored potential for applying machine learning? Because obviously it's being, as I said, applied across the board in things related to information retrieval. So the learning part of machine learning means that that you're developing algorithms, models that are based on the content of either the data or the metadata. And to train these models, you need lots of data. That's why machine learning is now a big buzz, because there's lots of data to train on, and lots of data to be well, used to be called mining, right? To pick things out of patterns or particular things of interest out of a very large corpus of data sets or documents. So probably the most the most obvious application is helping users discover data. That's what this group is about, based on its metadata or based on the contents of the data itself. So we tend to think of, in this group so far, repositories, data sitting in repositories, but as we know, a lot more and more data is just out there in the world wild web, and you've got crawlers like Google going out and looking for data and exposing it through structured data. And obviously one of the oh, I didn't turn my camera on, did I? One of the working groups that this interest group has spawned is the research schemas, which is to enable discovery of things out there in the world wild web. So there are several topics. So this is I'm just trying to do an intro here, and then I want to hear from folks what they think might be a worthy avenue to pursue, or some of the people who responded to the survey indicating interest in machine learning for data discovery. But clearly enhancing discovery by applying machine learning to associated resources. So I've seen some papers and presentations at recent conferences on finding data sets because they're mentioned in publications. And the more a data set is talked about in publications or in tweets and things, that increases its perhaps its relevance when looking for data sets within a repository, or again just out there in the wild web. Of course, Google data search is sort of leading the way in finding data sets based on these sorts of things. So RDA can't in itself pursue trying to recommend. Well, I suppose it can, but clearly the big players with the deep pockets are the ones who are going to push the edge here. Do the pioneering work in this way. So that's my sort of discussion lead-in. Can we open the floor or look for Q&A related to this? Geographic annotation compared to proximate, I guess. So, anyone who indicated...
we have about 7 or 6 minutes left.
Yes.
I think you raised good questions and topics. If you look at the project Makoto present, so there are already people use the machine learning, the models like BERT is one of those machine learning models. Then it worked. It seems that's leading models in Makoto's presentation, and as you can see from his presentation, lots of resources need to be involved in organized test collection, that's including query, relevance assessment, and etc. So we could consider, we probably it's hard for us to leading that that task, but we could partner with, say, Makoto's team and say if we could provide collections and also link, if there are external resource like top ontology, vocabularies, and the links to other resources, if we could provide such resources and co-run a data search track, then invite other people who develop models just to run their models, and the track organizers organize the evaluation. That probably, in my opinion, that's probably a way to go.
I think it kind of makes sense. If there is already an activity and what Makoto was discussing here apparently has a good connection, and I think he also put a point in the chat window about it. It may be a good initial effort, at least to investigate what the landscape is about in that field. So how to apply machine learning for data discovery purposes. So if there's already an activity there, I think it makes kind of sense to connect to that. The practical question I have in mind is how this would be better fit into the data discovery interest group. So if it would make sense to have it as a distinct activity, as a task force, or to mostly maintain a connection of seeing how this proceeds. I mean, it's a practical question I'm trying to figure out now. My suggestion, for example, would be to, and again, looking at the results of the survey, that there are people interested in the machine learning for discovery, it might make sense to start a dedicated task force about this in the interest group, see if there are other people interested in pursuing that, and maybe extend the efforts from NCIR across a different institution, different organization, see if they can be applied there directly and have some context provided from there. That's sort of my take on that.
Yeah, we have 3 minutes left. So the survey is still open for 2 weeks. We hope people on this call would participate in the survey. That would guide us to focus on activities that interest to most people and attract resources to join in. So we have top 1 categories with 4 tasks. We can approach to you filled in the survey to discuss how we could organize activities or task force along each this topic. So photosensor Yoda, what do you want to add?
Let's see. Yes. Well, the only thing I have to say, I guess, given the last 2 minutes, is to thank everyone for tuning in and asking questions. And thanks to those who filled out the survey. And I hope you put your name and email address there so that we can follow up with any questions or add or keep you informed on what we do going forward.
And definitely big thanks to both Michael and Makoto for giving their really, really engaging presentations. It were great to have them on board, and I feel that a lot of the participants had a lot to gain from those talks and the perspectives. So thank you both for attending and for your time in presenting here.
Thank you for having us here.
Yeah, thank you, Michael and Makoto and everyone in this call. And looking forward to see you in our future sessions, plenary sessions, or monthly calls.